4. 4 minus 3, positive 1. 2 times 3, 6. 6 minus 3, 6 plus 3 is 9. Yeah. Well, I mean, I guess sometimes some of the questions look easier than they really are. Like the first one is clearly the hardest one I did. Because that one had like something equal XY. Madness. Oh yeah. I'll never forget that one. That one made me go remember that for a little bit. Yeah. I was surprised at how yeah, this actually came out nice. I never expected that, to be honest. Did not expect that. Genuinely didn't. I promise you I did not. Alright, so Alright. What? Why am my tablet doing this? Come on. This is the last one. We can say that we used to do when we were at teacher school. I made the last day like the lightest day, you know, because after you go through the week you're tired. So what today is what? Today is Wednesday, so we can't even do that. I can't even, no, you see? No, it's not, yeah, it's fine. Anyway, 2.3x plus 1.8y equal 5.1, 0.9x, 2.4y. Alright, good. Alright, so if my tablet dead, you know, it's fine. Alright. What am I doing now? Right, the line. Okay, so here's what I believe. Just like before. Alright, hold on. Give me a second here. Yeah. So we're going to multiply everything by 10. Just multiply everything by 10. We're multiplying all of that by 10, this by 10, all of this by 10, that by 10. So it's going to look like 23x plus 18y equal 51. 9x plus 24y equal 3. Alright, so okay. So let's be careful with this now. You know what? Alright. Now I have to be real careful. The LCM of 9 and 23 is what? Unfortunately, the LCM of 9 and 23 is literally 9 times 23. So we just have to multiply 23 by 9. Right? So 230 minus 23, looking like 207, right? So therefore, the LCM of the LCM of 9 and 23 is 207. Alright? Because if you multiply 23 by 10, you get 230. 23 times 1, 23, subtract it from that, you get that. 10 minus 1 is 9, so if you multiply 23 by 10 minus 1, you end up with, so that is your 23 times 10. That's your 23 times minus 1. Yeah. So either way, that's going to be, so we want this to be 207x, and we want this to be 207x. Right? So we're going to get the two of them right there. Right? Yeah. So we have the two of them. So that take care of that. No, the 18 and the 24. 18 and 24 is different now. This is 2 by 3 by 3. So this one now we have to be a little bit more careful with it now. So circle this and circle that. So we're going to be using the 2 by 2 by 2. Can that have more space? No? So you want the biggest house for the family possible. Right? So then for the 3's now, we use this. So the LCM of 18 and 24 is going to be 72. So therefore, we're aiming to have 207x, and we're aiming to have 72y. So for one line, we're going to multiply this by 9, that by 23. Then on the other side, we're going to multiply, so I have to be careful now. I forgot that I never write the 72 in the full form, right? So 18, right, okay. So if you separate the 18 from everything, you're left with 2 by 2, so 18 is multiplied by 4. So you multiply the 18 by the 4, and then the 24 you multiply by the 3. Yeah, we can do that. So let's get rid of that. So we have the left side and the right. The X and the Y. So what we do to X on this side, what we do to Y on that side. So 23 times the 9 is 207x. So 9 times 23. So we're doing 9 times everything up here. So 9 times 23, then 9 times 18. So what is that now? So why did I do that? Look at what I'm doing. Why? Come on. 18, you know, not 180. So I need to be, yeah. Look at that. So it's 18 times 9. Okay, so we have 2 here, carry a 1. So 8 minus 2 is 6. Alright, so that will be plus 162. Y equal, what is it? You know, listen, this is too, let me move it over a little bit. I'll give myself some more space, yeah? So, 207x plus 162y equal what? 51 times 9? So that means this will be 500 minus 41. Okay, so 459. Alright, so 459. Alright, so so we're done with that now. Multiplied all of these by 9. So multiply this by 9, this by 9, this by 9. Now down here, we'll multiply everything by 23. So, how this are going now? This is the 207x that we got from before. So now we have 23 times 24. Well, fine. That's not hard to do. There we go. Alright, 23 times 4, that's looking a lot like 46 plus 46, which is 92. So this part is 92. 46 with a 0 at the end. There we go. Now this is looking like 552. So this is going to be 552y. And then now we have 23 times 3, which is 69. Okay, now here's what we're going to do. We're going to minus this from that, because these, if both of them were minuses, we would still subtract both of them. Once they have the same sign, or rather once they have the same, if both of them are positive, you subtract. If both of them are negative, you subtract. So they have the same sign in front of them. So we're subtracting this from that. So this is kind of weird. This is kind of weird. Alright, really? What is this? Yeah, sorry. 400 minus what? 59 from that, 400 minus 10. 390, okay. So this side is 390. Now, let's do this now. 552 minus 162. So we have what? If we take 52 from both of them, we're left with this. Okay, alright. Okay, so we have 390 on both sides. Except for this will be a minus 390 minus 390y. Yeah. So now we divide both sides by minus 390. So we divide this by minus 390. Minus 390. So y is equal to -1 on this side. Okay, so we have that. So let's be careful now. We are now moving over to the y's now. So let me get rid of these numbers here. The numbers that I'm going to use for 18 and 24 is going to be 4 and 3, right? So therefore I multiply everything up here by 4. Everything up here is multiplied by 4. Everything down here is multiplied by 3. Alright, why does that 3 look so deformed? Alright, so 23 plus 23, 46 plus 46. So that's 92. So we'll have a 92x right there. This is obviously a... Alright, so this is now a 72 y. What else now? Oh, 51 plus 51, 102 plus 102, so this is 204. Yeah, so that's 204. So 92x plus 72y equal to 204. This right here is equal to 9. This is equal to 72y. Hold on here. Let me see if I can use a little color to. There we go. 3 by 3, 9. 3 by 24, 72. 9 by 3, 27. X right there. So again, the signs that are in front of the 72, both of them are the same. So you're going to have to subtract line 1 from line 2, right? So 207 minus 207 is 0. 72 minus 72 is 0. Alright, so 92 minus 22 is 70, leaving us with 70 minus 5. 70 minus 5 is 65. We will have a 65x on this side. 204 minus 4, 200 minus 5. Well, that's 195. Now, something tells me that the number that I'm going to get here is 3. I just get the suspicion that that's the case. Alright? 65 plus 65, what that? 130. 130 plus 65, yup. So, if I divide the left and the right by 65, my answer for x is going to be a positive 3. So yeah. So that's the four questions that I left on the board from last time. And there are others. There's other madness that I've seen. But there's some other things I wanted to do. Like something to do with indices, something to do with surds. Oh yeah. What? Okay. I might as well do this one that I'm looking at. Seeing that I wanted to do indices anyway, might as well. We're looking at number 20, and number 20 looks quite different. Really? My board is about to betray me. It's about to fall. Fam, you can't be doing that to me. Alright. So let's look at this one. We have 27 raised to the x divided by 81 raised to the x plus 2y. All of that is equal to 9. And we also have x plus 4y equals 0. So 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5, 3 to the 6. So we have 3, 9, 27, 81, 243, 729. Now the reason why all of that is important is because all of these are powers raised from the base 3. Once you have 9, 27, 81, they're all related to 3. Therefore, fine. Based on this is a clue. They're telling us that x is equal to minus 4y. So if we minus 4y from here and here, x is equal to minus 4y. And if you add minus 4y to this, we end up with 0. So we at least know what one of our answers is. Alright? We know that. But let's simplify some of it. If 27 is 3 to the 3, let's just change that to 3 to the 3x, right? Because even if you did this, 3 times x, you're gonna get 3x anyway. So therefore, 27 raised to the x is 3 to the 3x. Now, what about this? We have to be careful with this. 81 is the same as what? 3 to the 4. So this becomes 3 to the 4. However, 4 is if we think about the distributive property, 4 is being multiplied by x plus 2y. Right? So, if we were to write it like this, then this would be, yeah, it would be something like that. I mean, Does it make sense for me to do that? Yeah, it probably does. All right, we'll do that. So we will have this, and we'll call it 3 to the 4x plus 8y, right? 3 to the 4x plus 8y. So you have this and you have this. So those are interesting things. Wait, hold on. Give me 1 second here. All right. Right. Now, what am I going to do with the 9? The 9 is 3 to the 2. This is, all right. No, this is just madness. I'm not even going to know with the 9 just yet, right? Because, okay, I think I know what's happening here. I think I know. This is a fraction. So I'm going to have to multiply both sides by 3 raised to this number so that I can end up with this being multiplied by that, or cross multiply. Right? I don't know. Yeah? So let's just say that this is right? So therefore, when this is multiplied by that, it multiplies by this as well, leaving us with three to the 3x is equal to all of that. So fine. And then of course this is 3 to the 2. So there's only one question that one can ask. Why did we have this? Well, fine, we're going to substitute it because at this point there's nothing else we can actually do. So we minus 4y from both sides, right? So minus 4y minus 4y, it's safe to say that right, x is equal to minus 4y. So the only thing we can do is substitute now. So if I take minus 4y, put here, that is 3 to the 3 times minus 4y. Okay, so if you multiply that, this is going to be 3 to the minus 12y. So this is 3 to the minus 12y. Now if I substitute it on this side, I'll have, you know what, let me just put back 9. Just so that I'm not confused. So now we have 3. Now 4. Alright. 4 times x is just x. 4 times this is minus 16y. So we will have minus 16y plus 8y. And the good thing with that is that 8 minus 16 is 8. So it's going to be a minus 8y. Now life nice, because now when we multiply 3 to the 2 by 3 raised to the minus 8y, when we group it together, it becomes 3 raised to the 2 minus 8y. And this is according to the indices rules, right? So for example, if you have 3 to the 2 times 3 to the, let's say, y, it becomes 3 to the 2 plus y. Now, similarly, if you had 3 to the 3 times 3 to the minus 4y, it would become 3 to the 3 minus 4y. And in simpler terms, it could have been this, resulting in 3 to the 3 minus 4, right? So if we follow those rules, then we're okay, right? So let's see what happened now. This is going to become 3 to the 2 minus 8y. Now finally, we have a 3 here and a 3 here, this here and that right there. Yeah, so this was a lot. Right? Because we wanted to use something that makes sense. Because when it's posed as a fraction, you want to get rid of the denominator. So get rid of that. Because anytime you see something like this, like a x over 7 equal, say, something like this, you always want to get rid of the 7. And that's what we had in the form of 3 to the whatever it was that we have under the line, right? We have 3 to the 3x over something, right? It was, oh yeah, it was 81 raised to the x plus 2y. Yeah? So therefore, you want to get rid of this, because that's going to give you a problem, right? All of this was equal to 9. The 9 is not the problem. This down here is. So you can multiply both sides by the denominator so that you can simplify the situation. Right? So that's what you want to do. So after we go through all of that stress now, we reach the good part now. So now we can focus on the exponents, which mean all we have is minus 12 y equal 2 minus 8y. If we add 8y to both sides, we end up with 8y minus 12y is equal to 2. Finally, we'll have minus 4y is equal to 2. So now we are going to divide both sides by minus 4. Y is going to be equal to minus half. Alright, because if I take minus half, put in here, the minus is cancelled. 4 divided by 2 give me 2. Alright, so if y is minus half, and I put that in here, 4 over 2, x is equal to 2. So we found the value for the y, and by finding this, we find the value for x. So that is why we had this in the first place. The x plus 4y equals 0. We had to make x become minus 4y, and we substitute it in what we have up here, right? Minus 4y times 4 minus 16y. Add it to 8y, you get this. Then you combine this with that. And then of course, you make this here equal to that. Because the whole point of when you deal with indices, exponent is equal to exponent. And then you just work with that. But yeah, if we understand the basics of indices and the rules, I mean there's what? There are 6 main rules. And they're not really hard to remember, right? Like, so let me give a few examples of it, right? So you have the multiply rule. So that's a multiplying rule. The dividing rule is that, right? So it's just an inverse, right? Now there is another rule. There's the inverse rule. So the inverse rule is something like this. Let's say I had 3 to the minus 4. 3 to the minus 4 is the same as 1 divided by 3 to the 4. And that's the reason why when you're dealing with a lot of things in maths, especially with later topics like trigonometry, when you see something like sine to the minus 1, then that principle comes from indices. And even in matrices, you have finding the inverse of a matrix that you use as like a raised to the minus 1. Right? So representing it like that, it comes from that, and also what you would call scientific notation. Alright, there's another rule. So these are the first 3 rules that well, I wouldn't say those are the first 3. This is another rule that's very important, that obviously that's the inverse rule for that. The other rule that's important is the distributive rule, right? Alright, we did this, so we can get rid of this, because those are the easiest ones to remember. Right? Those, that not too difficult to remember. So you have something like this. So once there are brackets, you are literally yeah, you have that. Now, mind you, there is a unspoken rule about, let's say, something like, what if you had 3a raised to the 2? Oh, hold on. I don't want it to just be that. 3 to the 3 times a raised to the 2, all of that raised to the 4. Now the reason why this is important is because I don't think a lot of people pay attention to this aspect of it. So yes, it's true that you're still going to have 3 to the 3 times 4, but also you're going to have a raised to the 2 times 4 as well. So then now, in this case, you're going to end up with 3 to the 12 and a raised to the 8. So you had this. Yeah. So the second part is an unspoken rule in indices. So meaning you're not just raising this to the fourth, you're raising everything in the bracket to the fourth as well. So everything that's on the inside of the bracket gets raised to the fourth. Believe when I tell you, a lot of times that gets overlooked. So if you're teaching this, you should also teach this. Right? That's yeah. Because that will trick you if you're not prepared for it. Now, what's the other rule that's very important? The other rule that's important is, and this one is fairly straightforward, and it goes like this. Any number that is raised to the 0 is equal to 1. It makes sense if you think about it like this. Remember the rule about this? There's a rule where you have 3 raised to the minus 1, right? And that is the same as 1 over 3 to the 1, right? But watch a joke. That is 3 to the minus 1. What about 3 to the positive 1? Well, that's the same as what? Just, you can write it the same, whether you can write it as 3 or 3 to the 1. It don't matter. Right? Whether you say 3 is equal to whatever. Yeah? You can do that. Now, there's a reason why I put these two together. Because a substitution for this 0 can be replaced by what? 1 minus 1, 2 minus 2, etc., right? 5 minus 5, whatever. But let's just focus on what we have here. The 0 equal 1 minus 1. It basically means that you can replace the 0 with 1 minus 1. But if you were to separate these exponents, it would end up looking like 3 to the 1 times 3 to the minus 1. Yeah. So this is the same as saying 3 to the 1 times 3 to the minus 1. But we know that 3 to the minus 1 is that 1 over 3 to the 1. So if we replace that with this, and then you divide this by this, then any number raised to the 0 is always equal to 1. And it don't matter what it is. So it could be 1 million raised to the 0, 350 raised to the 0. Anything that's raised to the 0, all is equal to 1. Every single time. Now there are other important indices rules. Another one. It's the ones related to what we do in changing the subject of the formula. So to put a long story short, the square root of A is same as A raised to 1 over 2. The cube root of A is the same as A raised to the 1 over 3. Now there are times when they get a little bit, what's the word now? They get clever with these a lot of the time. Because sometimes they say, well, what about if I wanted you to find A to the 3 over 2 and A to the 2 over 3? What would that look like? Well, imagine it like this. What you had before was 1 over 2. Well, if you were to separate that, the A raised to the 1 over 2 has a 3 on the outside. And the A raised to the 1 over 3 has a 2 on the outside. So what that basically means is, the first thing you do, cube root it, then square it. Or, first thing you do, square root it, then cube it. Right? Now, mind you, I have to be careful, right? Because that means square root the number first, and then the result of it, you cube it. Right? So square root first, cube it after, cube root it first, square it after. So we want to be doing that. So a lot of this context is necessary for when we go into these kind of questions here. And then of course, when you get accustomed to seeing numbers like 729, 7 raised to the 3, which is 343, there are certain numbers where just by looking at them, you know what they're related to. Yeah? When a number ends with 6, chances are, unless it's 256, the number is related to 6. So for example, 36, 216, 1296, 7776, every power of 6 ends with a 6. Powers of 5 always end with a 5. 525, 125, 625. What come after that again? 525, 125, 625, 3125, then 15, 625. Yeah. 15, 625 after that. And then you just keep, you keep going up in powers, right? The 2s are related to the 4s and 8s. The 3s are related to the 9s and 27s. Yeah, and then the ones that they tend to give you are the powers of 7, the powers of 9, the powers of 3, 4, 5, and 6. Those are the ones that they usually give you. I mean, you really get the 11s and the 12s, rarely. Most of the time is between the powers of 2 to 9. Right? They really start going into like 12, 13, 11. I mean, they'll give you 11 raised to the 3, which is 1331. So, some of them not really that difficult. Yeah. Is there another set of rules beyond this that I need to show? No, I think I showed everything. Because you have the square, you have the square root. So just so you know, it's for us. Oh, you know what? So just imagine that this square root is the same as this. One over 2. Imagine that this cube root is the same as our 1 over 3. And then of course everything makes sense. So if we were to rub this out, we get rid of that 3, we get rid of that 2. Yeah. So that would make everything make sense. So you can remember all of those indices rules, and of course matching your, and then of course you can go back in the opposite direction. So when you start go 3 to the minus 1, 1 over 3, then 1 over 9, 1 over 27, 1 over 81, 1 over 243, 1 over that. Right? So you just know. To the minus 1, 1 over this. To the minus 2, 1 over that. Minus 3, 1 over that. Minus 4, 1 over that. Yeah, so that's yeah. There, you know, let me see if I can find that question. Because maybe if I show that question now, it would make more sense. Yeah, I'm looking for it. What? Oh. Oh, that's it? Okay, hold on. Let me go in the other direction now. There was one that I saw. No, I don't want that. Alright. I didn't want to do this one, but since that's what I have in front of me, I'll work with it. Alright. So let me do this real quick. Because, you know, what we did a while ago was a harder version of some of those questions. So let's go into this. So let's see what we're going for this now. It says 9 raised to the 4x plus 5, right? Is equal to 729 multiplied by 81 raised to the x minus 2. So there's a lot to unpack there, right? Now, I know that this is 3 raised to the 6 based on what we did before. So we know that. This is 3 raised to the 4, which is being multiplied by x minus 2. So that's going to be, just on this side alone, 3 raised to the 4x minus 8. Now, based on our rules of indices, let us say we have 3 to the 6 times 3 to the 2. It means we have 3 to the 6 plus 2, resulting in 3 to the 8. Now, for context, it means we're going to add 6 plus 4x minus 8. So if I were to remove this and do this, yeah, that is exactly what would be taking place, right? Now 6 minus 8 is minus 2. Therefore, when we're done with this, we'll end up with 3 raised to the 4x minus 2. Alright, so we're done with the right side. Now over here, we have what? 3 raised to the 2, 4x plus 5. This is 3 raised to the 8x plus 10. Now, let's look at exponents carefully. This is 8x plus 10. This is 4x minus 2. Alright, so now we forget about the bases. 8x plus 10 equal 4x minus 2. We minus 10 from both sides. So that's what now? 4x minus 12 on this side. And then we just have this. Now we're going to minus 4x from both sides. So we're going to have this. Now we will have 4x is equal to minus 12. So first we'll have this. Last thing we need now, we divide this by 4, that by 4. So now we have, finally, we have x is equal to minus 3. Yeah, so let me see if I can find another one. Alright, this one is similar, so I'm going to write it and see if I can make my way to that answer. But this is based on powers related to the number 7, right? So let me go now. 7 times 7 to the 3x minus 2. And then we have 343 times 7 raised to the 2x. Alright. So, that's already 7 raised to the 1. If you add 1 plus 3x minus 2, you're going to have what? 3x minus 1. So meaning what is happening here is this. One minus 2 is minus 1. We would have what? 7 to the 3x minus 1, right? Now this is 7 raised to the 3. Obviously that is 2x plus 3. Really? Come on. Now we'll have 3x minus 1, 2x plus 3. then we do what we need to do. Add 1 to both sides, resulting in minus 2x from both sides. Resulting in zero plus 4 being just 4. Yeah, that. Well, that worked out itself rather quickly. I was looking to see if I could find another one. But yeah, I don't seem to have it on this machine yet. But it's fine. I feel like I've done enough for now. So yeah, I think we will start again tomorrow, same time. So we'll see how that goes. Now, if there's any, what I'll do is I'll see if I can find more of this, as well as the simpler examples of, oh, you know what? There's one more thing I want to do. I want to show what would happen if you run into a situation where you see something like one of these. So for example, what if you were given alright, I'm going to be ridiculous. What if you are given 128 raised to the 3/7? Now, mind you, this not so difficult, because really and truly, as we so for example, if we're looking at it like this, what is really happening is you will have 128 raised to the 1/7 with the number 3 on the outside, right? The reason why they do this is because they know that this number, when raised to a power, will cancel out that one, right? Therefore, they know that this is going to be 2 raised to the 7. So that they cancel out. Obviously, the 3 don't change. So 1 times 3 is 3. 2 raised to the 3 now. So therefore your answer is 8. No, you never have to do like that. We could have do it like this as well. We could have do it like so. What if, similarly, you know that this is 2 raised to the 7? So fine, 2 raised to the 7. Put it in a bracket by itself, because this would be in a bracket by itself. Well, what's on the outside? The outside is 3/7. But this is 3/7. I mean, so now you have 2 raised to the 3, resulting in So either way, you end up with the same thing. Alright, I'm looking at this other one. What about 243? So let me try that. 243 and you're raising that I mean, it could be 2 over 5, it doesn't really matter. Whether it's 2 over 5, 3 over 5, whatever. But what do we know about 243? Well, you have what? Just by counting, you know what it is. 1, 2, 3, 4, 5. That is 3 to the 5. So, if we were to bracket this, and we were to call this 3 to the 5, that means the 3 over 5 will not change on the outside. Alright? 3 to the 3, that is going to be 27. There you go. Now mind you, there is something that looks like a bit of a nasty trick, right? What if you had something like 27 raised to the minus 2 over 3? I mean, it worked out itself, really. It really worked out itself. Because what you ever do? Same thing. 3 to the 3. So now you have 3 raised to the minus 2. Which is what? 1 over 9. Or 1 over 3 to the 2. Yeah, it done. Yeah, I think there's only one time it really gets actually crazy. So let's try this last one before I go away. Imagine you have, let's say you have 64, and you put that over 729. You raise this number to minus 5 over 6. Well, imagine if it was a whole number. Well, if something is raised to a minus figure, it's 1 over that figure. So I would imagine that the same is true here, except it's a fraction this time. So for example, if you have A over B raised to the minus 3, what you really have is Something like that. That's where it gets tricky. So, to make your life a little easier, you can flip it from early. So turn 64 over 729 to 729 over 64 and make that exponent positive. Either way, you're going to have to do it at the end, because it's going to come out the same. So let's see if it actually materializes into truth. So let's have left and right then. Okay. There's a certain number here that you can raise to the 6. Alright, fine. That means I have 2 over 3 that I raise to the 6. But all of this is raised to the minus 5 over 6. So now I have 2 over 3 raised to the minus 5. So fine. What I have is 3 over 2 raised to the positive 5. So that's meant to be, that's going to look like 243 over 32. Alright, fine. Let's do it the other way over here. Let's flip it from early and have 729 over 64 raised to a positive 5 over 6. Of course, I have positive 3 over 2. All of that raised to the 6. But all of that raised to 5 over 6. It end up just like that. So 3 raised to the 5. Yeah. Exact same thing. Yeah. So you know what? That's it. I'm not going to hurt nobody else's brain. Right? So enjoy the rest of your day. And yeah, I believe we all deserve a break, eh? So, if anything tomorrow again.